Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is a cyclopentane 1,1 dicarboxylic acid derivative. At C1 there are two CO2H groups, a gem dicarboxylic acid. The ring also bears two methyl groups at other positions with defined stereochemistry. Moving on to the next step. Understand decarboxylthione of gem dicarboxylic acids, malonic acid type decarboxylthione when a carbon bears two carboxylic acid groups, malonic acid type, heating causes loss of one CO2 to give a monocarboxylic acid. This is a well-known thermal decarboxylthione. Moving on to the next step. C1 originally has two identical CO2H groups and is therefore a quaternary carbon with two identical substituents. After losing one CO2, C1 becomes a carbon bearing one CO2H, 1H, gained after decarboxylthione, and the two ring carbons. The key question is whether the loss of CO2 generates a new stereocenter at C1 and how many stereoisomeric products result. And for the final step, assess the new stereocenter at C1 after decarboxylthione. Before decarboxylthione, C1 has two CO2H groups, identical, so C1 is not a stereocenter. After decarboxylthione, C1 gains an H and now bears H, CO2H, and two different ring carbons, C2 with one methyl configuration and C5. This could in principle create a new stereocenter. However, the two CO2H groups are homotopic. C1 is a plane of symmetry position with two identical groups, so loss of either CO2H gives the same product. Consider the overall stereochemistry of the molecule. The molecule has defined stereocenters at C2 and C3, the two methyl-bearing carbons. The decarboxylthione at C1 proceeds via a cyclic transition state and the proton is delivered from the carboxylic acid itself. The reaction goes through a six-membered cyclic transition state, beta-keto acid or malonic acid mechanism, and the configuration at C1 in the product is fixed by the geometry of the ring and the existing stereocenters. Because the two CO2H groups on C1 are identical, homotopic in the context of the symmetric gem dicarboxylate carbon, removing either one gives the same constitutional product. The ring constraints and existing stereocenters at the adjacent carbons mean that the new H at C1 is delivered in only one specific facial orientation relative to the ring, giving only one stereoisomeric product. A. 0 is wrong because decarboxylthione does occur readily for malonic acid derivatives. C. 2 and D. 3 are wrong because the rigid ring system and the homotopic nature of the two CO2H groups restrict the reaction to give a single stereochemical outcome. Only one product is formed. Therefore, the correct answer is B. Therefore, the correct answer is option B.